Alright, now I want to talk about ventilation systems. It is so important to have ventilation in your house. The building code makes you put extraction in to get rid of smells, odours, condensation for the kitchen, the bathrooms and the laundry. You need to have ventilation for that. I'm not going to talk about that now, that's just a building code thing and that's just really good practice. What I do want to talk about is fresh air ventilation. Ideally, you're getting a lot of free cooling and fresh air and heating potentially coming in through openable windows. You always want to have openable windows in your house. I know it's a great idea to seal up a house. It saves some energy, but you don't want it to get stuffy. You want to make sure that you can bring it in. If you can do so by windows, that's awesome. If you don't want to do it by windows and you'd rather bring in forced mechanical ventilation, what does that mean, Michael? Well, forced mechanical means fan-driven ventilation. Now, in winter, if I want to pump lots of fresh air into my house to make sure that I stay awake, it's nice and fresh, I've got great air quality, that's great. I'm going to bring the fresh air in, the air's going to get heated, but where's the exhaust air going to go? I've now heated all this air in my house and I want to retain the benefit of that heat. But if I push fresh air into it, well, it's going to go out somewhere else. Is there another way? How can I make sure that I can keep some of that energy in the house but still keep it fresh? Aha, there is a way. There's a device called a heat recovery ventilator. It's called an HRV system, not to be confused with the company HRV. That's a different beast altogether. An HRV system, what that does is, if you can imagine some cardboard or a real estate agent sign which is made of core flute. So you look at a cardboard and you look end on and it looks like a honeycomb pattern. Every second one of those has got your nice fresh incoming air coming into it. From the outside through a duct into this unit. The air from the outside, the warm air, and maybe the smelly air, or maybe the air that you want to change over, goes out every other hole. So holes number 1, 3, 5 and 7 are the fresh air coming in. Holes number 2, 4, 6, 8 is the air going out. Now what happens? That cold air in winter that comes in almost touches the warm air going out. There's a very fine piece of material that runs between them. It could be aluminium, it could be paper, there's a whole host of different materials that it could be. But basically what it does is it means that the cold air coming in absorbs the heat from the warm air going out, basically preheating that air. So you're making sure that you can keep some of that energy inside. Now these systems work really well. You do have to be careful about where you're going to put your ducting, where your inlet and outlet's going to go, the noise of the fans and how it works. But that is a fantastic way of making sure that you have plenty of fresh air in there and that you're not dumping all of that energy that you had before. It has another benefit called a bypass, meaning that if it's too hot inside and it's a cold day outside, that it can just pump your house full of fresh air, not do any heat exchange, and just dump the exhaust, smelly, stale air into the outside and still fill it full of fresh air. One thing you do have to be really careful of, when you have got a system which takes air from a ceiling space, you have to listen to their advertising very carefully. There's some false advertising out there or very deliberately misleading advertising. And what that will tell you is, hey, you've got all this heat in your ceiling space and your roof space throughout the year, and it'd be fantastic to pump that into your home in winter. Now, yes, over the year there is a lot of heat in that space, but that's not in winter. In winter it's cold. You're not going to be bringing this fresh air into your house deliberately when it's cold, because that's what happens in summer when it's warm. But in summer, you don't want to bring that hot air into your house because that will make you cook. So just be very careful about who you're listening to and the advertising. Am I actually able to bring warm air from my roof space into my house when I want it? Or does it just not exist and there's a very clever company doing some clever marketing? I'll leave that one with you. However, if you do go for one of those companies, just be aware, many New Zealand insurance policies say, if you have one of those systems and it's cold in winter and you elected to take on that company's guarantee and the guarantee said, hey, if it's too cold, we can do something about that. And all they will do is put a heating element bank in your roof space. What's that? It's like a giant hairdryer, meaning the fresh air from the roof space as it comes into your house, it gets heated by an electric heating element bank, very expensive to run, and into your house. But you're like, woohoo, the system's fantastic, my house is nice and warm, I've got no condensation, this is awesome. That's because you pay quite a lot for it. If you have one of those systems in your roof and it has the electric heating element bank in it, if there is a fire and you haven't had that maintained on an annual basis, your insurance company will not pay out. You need to be extremely careful if you are specifying for clients, or if you are the client and you are putting one of these in your houses yourself, that you read the fine print of your insurance premium, most of them will say that you need to get a qualified person to come in and maintain that. Why? Well, you can imagine your hairdryer getting all dusty, and once that dust builds up, it catches fire. What faster way to spread a fire through your house than a ducted system blowing flames through each and every room? It does not give the fire appliances enough time to get to site and to put it out. So be warned, be very, very careful. If you're going to go for those systems, make sure they're maintained. Check the fine print in your insurance. I don't want you getting burned. All right, how are we doing? Hope you're not getting too bored out there. It is a reasonably dry subject, but we'll try and make it as entertaining as we can. So far, we've talked about your body. Well, not actually your body, sorry about that. We've talked about the impact of radiant and temperatures on your body and what makes you feel comfortable. We've looked at glazing, insulation, thermal mass, ventilation, a few other things. But right now, we're getting into the crux of why we're here. I want to talk about heating and cooling options. There are three main things that I want to cover off. There's the old school style of spot heating. Spot heating is the way it has been traditionally done. It's one room with one heating source. That was often a fireplace. Could be a single heat pump, could be a high wall heat pump or a floor mount heat pump. The second option I want to talk to about is central heating. Now this is normally one heating source and that distributes heat throughout the house or to selected rooms, not just one room though. The third option is air conditioning. This provides heating and cooling. It could be to one place in the house, it could be to multiple places. So they're the three things I want to really get into today, and I want to look at how much each one of those costs to install, how much each one costs to run, and the efficiencies for that. So for this, you really want to have the book, and then you can look at some of these charts and pictures as we go. Before we get into the nitty-gritty of the heating systems and cooling systems, I really want to explain to you about how much energy is used by these and how much energy costs. Electricity, there's basically two rates for that, and depending on where you are in the country, those rates can fluctuate significantly. But in general, on night rate, if you have a day rate and a night rate, the day rate is when it's normally peak power and the power's a bit more expensive. Supply and demand, right? It's pretty obvious stuff. So at night, you get it cheaper and it's around 16 to 18 cents per kilowatt hour. During the day, you might be spending 24 cents a kilowatt hour. So if you're doing some heating overnight, that's great, it's a bit cheaper, but you might not use it because you're probably not sitting in front of the heater if it's in the lounge, say. Now, I want to work out how much do things cost. Let's say you've got a standard size lounge. Your lounge might have a couple of couches in it, it's got a TV, it's enough space for maybe 5 or 6 people to sit down. You work out, what kind of heater would I need to keep that lounge warm in winter? And it could be a bar heater on the floor. If it was a bar heater or a fan heater on the floor, that's probably 2 to 3 kilowatts. And if you have that thing turned on, it will use in 1 hour, let's say it's 2 kilowatts. In 1 hour, a 2 kilowatt heater will use 2 kilowatts of electricity. Now, if that is during the day, at say 24 cents, you have used 48 cents worth of power to run that fan heater. You plug it in, you turn it on, it gives you 2 kilowatts of heat, and you have paid for 2 kilowatts of power. 1 kilowatt in, 1 kilowatt out. There's no real efficiency with these things. It's the same for a panel heater. You need 2 kilowatts to keep your room nice and warm in winter, so you plug your panel heater in, and it works well. It gives you 48 cents worth of power at 2 kilowatts. If you were to run that at night, at say 2 o'clock in the morning, it might cost you 2 lots of 16 cents per hour. That would be 32 cents. So it depends on when you're going to be using this, how big your space is, how many kilowatts you actually need to put into it. 2 kilowatts isn't much, but generally it's okay for a small to medium sized room. So now that we know how much these things cost, what are the differences in how they work? An oil column heater works quite well by you sitting on it, keeps your backside nice and warm, but the way that it works is it gently allows air to go around it, to move up to the ceiling, and the warmth slowly comes down and fills the room. It's not good at being directional, it can't blow on you. A fan heater is different, it's giving you the same amount of heating but in a different way. It's blowing it at you and creating a draft, but if you're sitting right in front of it, you're going to be nice and warm compared to sitting on the backside of it. Nana's bar heater, I'll keep coming back to this one. Nana's bar heater sits in front of you. It points at you. It can be very hot even though it's 2 kilowatts. It also does heat up the air in the space from top down, but you're getting the benefit of radiant. A fan heater, no radiant, it's all temperature. the column heater, like the oil column heater on little wheels that you roll around, that's giving you some radiant, but a lot of convection out of that, warming the air temperature and making you feel warm. Nana's radiant heater, there's no convection basically coming off that. It's almost all radiant, although it is heating up the air somewhat. Heat pumps are another form of spot heating too. Now, a heat pump, I have heard that a heat pump can be quite cheap to run. You pay for a kilowatt and you get 3 kilowatts out of it. How does that work? Let's look at this example for a second. Let's say I've got a pot of boiling water and it's sitting on my stove. That pot of boiling water is boiling away. If I put my hand into that boiling water, it is going to hurt and I'm going to take it out pretty quickly. But if I'm fast enough, I'm not going to get too bad a burn. Now, let's say that I put my hand over the top of that boiling pot of water and I leave it there and I get the steam that comes in. What am I going to get the worst burn from? Is it going to be the boiling water or is it going to be the steam? Steam, you are right. And why is that? Well, you might remember back to school, 5th and 6th form, where to change phase of something involves putting a lot of energy into it. What do you mean changing phase, Mike? Well, changing phase is changing something from a solid to a liquid or a gas, or backwards, or any of those three, changing to one of the other ones, right? So if I've got water, I need to put enough energy into that I'm going to turn that water into steam. And as the steam comes up out of the top of that pot and then collects on my hand, it collapses from a steam back into liquid again, and all that extra energy that I put into that water to make steam, that steam will release that energy back into my hand. So not only am I getting a hot burn, I'm getting a whole lot more energy than I would previously, which is no good. That's giving me a terrible burn. Well, that's very well and good, Mike. So steam burn is worse than just the normal old water burn. Yes, that is true. Well, how does that impact the heat pumps that we're talking about? That's a good question. Let's say I wanted something that could boil at a low temperature, conveniently low, like minus 15 degrees, right? That'd be quite nice. There is a product and it's called refrigerant, and it's what forms the basis of most air conditioning products. So at minus 15 degrees, I've got this refrigerant product. It looks like oil, feels like oil, smells like oil. Whole range of different products around. Have to be quite careful of which ones you ultimately select, because some have got global warming potentials higher than others. So it is mandated, don't worry about that. Modern gear is the right stuff to use. Anyway, outside I've got a heat pump sitting there. There's a fan in that outdoor unit that has got a radiator in it. Inside that radiator, like your car radiator, it's not filled with water, it's filled with refrigerant. And I've got air at, say, in winter, 0 degrees, going past that. And the minus 15 degree boiling point for refrigerant means that anything more than minus 15 degrees, I'm going to boil my refrigerant and turn it to refrigerant steam. Oh, that's good. If I have refrigerant steam, that means I can have this high energy gas in my system now that if I was able to collapse back down again, I could get some good heat out of. That's right, that's how it works. But wouldn't that mean that the amount of heat that I put into that refrigerant to boil it, wouldn't that mean if I just simply collapsed it again, that I would just get the same amount of heat out of it? Yes. Well, then how do we get the extra efficiency? Well, I don't know if you've ever tried this before, but if you get a balloon and you squeeze it really hard, it gets hot. It changes the temperature difference for it. When you compress something, you make it hotter. So what we do is we tell that outdoor unit to get nice and warm from the air. Even though the air is freezing outside, it's still warmer than that boiling point. It boils that refrigerant gas off. That gas then comes into a pipe. And what we do is we then squeeze that gas, and that makes it quite hot. So suddenly you've got hot refrigerant gas that comes into your house, and it might come in at, say, 55 degrees. Well, what's the temperature of the air inside your house around your indoor high wall heat pump, which is sitting above your head in your room? What temperature is it? Well, it might be 28 degrees. It could well be 28 degrees. Is that 28 degrees less than the 55 degree refrigerant gas? Yes. So there's a good chance, like my hand being colder than that steam from the boiled pot of water, that refrigerant gas is going to collapse and release all that extra energy? Yes. You have just understood how heat pumps work. By doing the cheap squeeze process, you get really, really hot refrigerant gas that you can then collapse down again and get extra energy out of. And that is the crux of how you get the extra energy out of it than what you paid to put into it in the first place. So, heat pumps, are they cheaper than fan heaters and normal electric heaters like your bar heaters, your fan heaters, your column heaters, your night store heaters? Yes, they are cheaper to run, normally by a factor of 3. So if I'm spending during the day 24 cents per kilowatt on my bar heater or fan heater, my heat pump should be running at a third that at about 8 cents per kilowatt hour. Well, that's pretty good, nice and cheap. Yes, it is cheap. They are more expensive to buy because they got more components and they squeeze refrigerant and things like that. But yes, that is where you are getting your cost saving from. So let's talk about spot heating heat pumps. You've normally got a high wall heat pump or a floor mount unit. High wall heat pumps are great. They work in heating and cooling. They react really fast. So long as they're size big enough for the room, they should work just fine. Floor mount units, they are also really good units too. They are more expensive than the high wall units, and you often run into issues with whereabouts you're going to put this because you've got furniture around the place too, and you don't want to put things in front of it. You also don't want to drop Lego down it, so if you've got young children, you need to be careful about that too. But they do work well. However, they are drafty. They have no radiant ability whatsoever. They are just throwing air around, creating a draft. Now in heating, that's fine. Your body normally doesn't mind a hot draft on it, but in cooling, it can be a bit of a pain. And when it's not heating or cooling because it's up to temperature, it still needs to run a fan to turn the air over so it can realize what is the temperature in this space. And that's the bit that people find drafty and can dry their eyes out. So we do need to be careful. Excuse me. One thing I do need to say about the heat pumps for spot heating and any type of heat pump is what happens when it's cold. I'm boiling my refrigerant off at minus 15 degrees, any temperature more than that. But sometimes I've heard that the outdoor units can freeze up. Why is that? Well, because the system is working at such cold temperatures, as that refrigerant boils off, the actual fins and that little radiator that sits outside does actually get quite cold, and any moisture in the air, so not the refrigerant that sits inside the system, but the air that the fan is blowing over it, that's got moisture in it, and the moisture condenses, like we've talked about before, on those fins. And the more moisture that condenses, the more ice that forms, and the more ice that forms, the more it blocks up all those little gaps in that in the radiator, sorry. So at that point, the fan can't push any more air through because it's totally blocked up with ice. So how do we fix it? The unit goes into reverse mode. It sucks some of the heat from inside, runs it back through that radiator in complete reverse cycle to what we talked about before, allowing you to defrost the outdoor unit. So sometimes you'll hear a funny noise outside and you'll see a steam cloud coming out of your heat pump. That is it getting too cold. Now the way to get around that is, 1, make sure you buy a reputable brand heat pump. The cheaper ones perform worse at lower temperatures and freeze up more often. If I buy a 7 kilowatt Daikin, Mitsubishi, Panasonic unit, they will work well at lower temperatures. If I buy another brand, as the temperatures drop outside, they will defrost more frequently. They will ice up more. It will cost you more to run it. And right when you want the heat in the house, it's going to decide to go into reverse mode more often.